Welcome to this explainer. Today, we're diving into a development that is quite literally turning the established tech world upside down. We are going to unpack a brand new, incredibly dense 58-page research paper that details the arrival of DeepSeek V4. So, if you're the kind of person who loves understanding exactly how cutting-edge technology works without getting completely bogged down by the media hype, you are in exactly the right place. I mean, it's the ultimate David versus Goliath story of our time, right? Just think about it. How on earth does a completely free, open-weights AI model step into the ring with massively funded, closed frontier systems built by absolute tech giants and not just survive, but actually win? What kind of architectural magic is going on behind the scenes to make this a reality?
Okay, let's jump right in. 1 million. This number right here represents DeepSeek V4's context window. To put that into perspective for you, this AI can essentially inhale about 1,500 pages of dense documentation in a single prompt. Just a couple of years ago, when Google first introduced this capability, the entire industry flipped out. It was a huge, highly exclusive premium feature. And now, DeepSeek is offering the staggering 1 million token context window in an open weights model. It feels almost absurd, honestly, like a total gift to us mortals.
And when you look at the actual performance data, the juxtaposition is just staggering. Researchers ran something called the Hidden Fact Recall Benchmark, where they hid 8 specific facts inside increasingly long chunks of text to test the model's memory. DeepSeek V4 Pro actually outperformed Gemini 3.1 Pro, which is Google's flagship product. And if you look over at the pricing column, if you use the online access, DeepSeek can run anywhere from 8 to 20 times cheaper, and with certain discounts, up to 30 times cheaper than Anthropic's Claude. It completely breaks the established pricing models of the entire AI industry.
But the efficiencies don't stop at just the pricing. They're baked right into the hardware requirements. As the AI continuously generates more and more text, the DeepSeek Pro model requires about 3 times less computing power than its previous iteration. And their lighter model, DeepSeek Flash, that one requires 10 times less computing power. They've fundamentally reduced the computational heavy lifting. But obviously, this raises a massive question. How exactly are they pulling this off?
Section 1. The magic trick. 3 layers of compression. To understand how they pull off this magic trick, we have to look at DeepSeek's secret weapon. It relies on something so elegant, it completely changes the game for how AI processes our prompts. We need to talk about the KV cache. You can think of the KV cache as the AI's computational scratchpad. Whenever you give it a prompt or upload a huge document, it writes that information onto the scratchpad so it can refer back to it. Imagine trying to search through a massive book to answer a question. If the book is huge, reading every single page over and over takes forever, right? So DeepSeek decided to aggressively compress this scratchpad. And the crucial part is exactly how they do this, using 3 distinct layers of compression. First up, we have token-level compression. Imagine compressing every single paragraph of that massive book down into a single summary sentence. You still have the book, but now you can scan it way faster. Second, they use heavily compressed attention. If you just want to know the overall plot of the book, you don't read the summaries. You just look at the table of contents. DeepSeek compresses information at a 128:1 ratio, giving the AI a quick glance at the whole story instantly. Finally, compressed sparse attention. If you're looking for a specific fight scene, the table of contents isn't going to cut it. You need the book's index at the back, pointing you exactly to the top 5 pages that mention fights. Summaries, structural index, and sparse attention.
By stacking these 3 compression techniques together, DeepSeek reduces the memory needs for that KV cache by an astounding 90%. They are literally squashing 100 words of data into a storage space of just 10, completely without losing the core pieces of information necessary to recall facts perfectly. It's brilliant. But let's pause for a quick reality check here. As focused learners, we know better than to just fall for media hype. This 90% reduction, that only applies to the KB cache, the scratchpad. You still have to load the entire neural network model itself into your system to make the whole thing work. So despite these incredible efficiency gains, you definitely cannot run DeepSeek Pro on a toaster. It still requires some serious, pricey hardware if you plan to self-host it.
Section 2. The forest walk. Local detail versus global context.
This compression architecture actually builds into a really incredible philosophical metaphor that was introduced by the researchers themselves. Imagine you're taking a walk in a beautiful forest. You want to look up and take in the amazing views, right? But if you do that the whole time, you're probably going to trip over a tree root. So you look down at your feet to watch your step, but then you completely miss the view. As a human, you naturally adapt. You scan near to step safely, and you glance far to see the whole forest. Step and look. Local detail, global context. In our AI, the step is the compressed sparse attention, finding those exact local details via the index, while the glance is the heavily compressed attention, taking in the overall plot. This is exactly how DeepSeek processes data. It uses these intricate attention mechanisms to hyper-focus on local details while still maintaining a global context of that entire 1,500-page document.
Section 3. Ngram. Recalling the facts. Now, compression isn't their only trick. DeepSeek also utilizes another massive efficiency technique that fundamentally changes how the model retrieves information. They use something called Ngram. Normally, traditional AI models are incredibly computationally expensive because they literally recalculate nearly every single fact from scratch every single time you ask them a question. Ngram changes the architecture so that the AI can simply recall a saved fact instead of doing the math all over again. I know it sounds like a totally simple fix, but structurally, it's incredibly advanced and it saves a massive amount of computational power.
And because of all these efficiencies, the model is lightning fast and shockingly capable, especially when it comes to programming. As the paper's reviewer noted with immense enthusiasm, if you are not a coder, well, you are now. You can ask DeepSeek to generate JavaScript code, paste it into a website, and just run it instantly. In some cases, you can execute programs directly within the DeepSeek interface with a single click. It flawlessly handled a light transport ray tracing task, though, to be fair. It did struggle slightly to implement some highly advanced niche algorithms, but for everyday coding, it is absolutely phenomenal.
Section 4. The catch. DeepSeek's limitations. Okay, but our explainer wouldn't be complete without swinging the pendulum back to reality. It's absolutely crucial we look past the glowing headlines and understand exactly where this system falls short. So here is the catch. First, DeepSeek V4 is unimodal. It is entirely blind and deaf. It can't process images, video, or hours of audio like some of its competitors. It strictly processes text and code. Second, while it boasts that incredible 1 million token context window, if you actually push the model to that absolute limit, it suffers from context drift. It starts to forget things, degrade, and hallucinate, meaning more text can sometimes mean less truth. Finally, in a moment of sheer, wild transparency, the creators actually admit they use two techniques to stabilize the model's training that they don't fully understand themselves. It's a great reminder that all of this is still highly experimental science.
Which brings us to our final thought today. We are looking at a system that perfectly matches billion-dollar frontier models, utilizes absolutely brilliant architectural compression, and is actively crashing the cost of computing. We are rapidly approaching a world where high-level artificial intelligence will simply be too cheap to meter. It's just going to be a background utility like electricity. So the question I want to leave you with today is this. When world-class AI costs almost nothing, what amazing things will we build next? Thank you so much for learning with me today, and keep exploring.